Hello and welcome to video number 21. My name is At-Tayyib Abul Yaman. This video is about the basics of functions, that is, things that we must know about functions. And this would be a good review for the gurus of calculus, and it will be a good introduction for people who just started learning about calculus. So let's get going with the definition to start with. The definition states, if the value of a variable y depends on the value of another variable x, then y is a function of x, denoted by y equal to f of x, if and only if every value of x in the domain of the function relates to a unique value of y in the range of the function. Before we go through the characteristics of the function, we want to ask a question. And this question is about identifying a unique property for each of the following figures, the figures to follow. One of the figures has two properties. So let's first of all furnish the context. We have the domain and then an arrow. This arrow indicates that the function maps members of the domain to members of the range. And our domain is populated by values of x, and the range is populated by value of y, where y is the dependent variable and x is the independent variable. So changes of x cause changes in y, and that's why x is the independent variable and y is the dependent variable. And this is the range. So the range contains all values that y can take, and the domain contains all values that x can take. Let's take a look at an example of a function. This function has two values, 1 and 2 in the domain, and in the range it has three values, a, b, and c. And it's clear that the function maps 1 into b. That means f of 1 equals to b and f of 2 equals to c. The mapping is also one element from the domain is mapped to a unique element from the range. 1 mapped to b, and element number 2 is one element also mapped to a unique element in the range, which is c. So that's why this mapping is pretty much one-to-one mapping. We also realize that a is not mapped to by any element from the domain. And another thing that we have to remember is that every element in the domain is mapped by the function. So this type of mapping is characterized as follows. The function maps every element in its domain to a unique element in its range. And that's why this mapping is called one-to-one. One-to-one. That means no single element from the domain is mapped to more than one element in the range. So the mapping is absolutely unique. Let's take a look at another function. So let's suppose that we have this function. Now we can observe that the domain has now 4 elements. And also another thing that we have to observe is that a now is mapped to by a member of the domain. So let's take a look. Is this mapping one-to-one? We can see that 1 is mapped to c and 3 is mapped to c. So 2 elements from the domain are mapped to the same element in the range. So this is not a one-to-one mapping. But one thing that we observe for this function is if we look at the range, we know that a was not mapped to in the previous example. But in this example, a is mapped to, and every element in the domain is mapped to by elements from every element in the range is mapped to by elements from the domain. So this type of mapping is called onto. This type of mapping is called onto. So this mapping, the mapping covers every element in the range, and that's why it's called onto. The function is called a function that maps onto, but it's not one-to-one. Why? Because as we said, c in the range is mapped to by 2 elements, 1 and 3, and that's why it's not one-to-one. Let's take a look at another function. Oh, this function has two properties. The second property, we already mentioned it, but it says the function maps more than one element, that is two elements, and that means 1 and 3. More than one element in its domain are mapped to a single element in the range, and that's in reference to 1 and 3 mapped to C. So let's take a look at another function. This function, let's see, is this function 1 to 1? I don't think so, because 1 and 3 are mapped to C. So two elements from the domain mapped to a single element from the range. That means this is not 1 to 1. Is this function onto? It's not onto, because not every element in the range is mapped to by an element from the domain. Basically, B is not mapped to. So this is neither 1 to 1 nor onto function. And the mapping is neither 1 to 1 nor onto. Let's take a look at another function. If we look at this function, we know that this function is 1 to 1 because every element in the range is mapped to by a single element from the domain. And obviously every element in the domain has to be mapped by the function. So this is indeed is a 1 to 1 mapping. But also we realize that the range, every element in the range is mapped to. So this is 1 to 1 and onto. This is a function that is classified as 1 to 1 onto. So the mapping is 1 to 1 and onto. Let's take a look at another function. Now the functions we're going to be looking at now, they are not really a function. They are not functions, they are relationships. Every function is a relationship, but not every relationship is a function. Let's take a look. Here, this is not a function because there is violation. We said to be a function, every element in the domain must be mapped by the function. And we know that 2 is not mapped by the function. So the problem here is mapping violation at the domain. This is not a function, it's a relation. Let's take a look at another example. This is another example. Let's take a look at this example. Is this 1 to 1? Let's say 1 is mapped to C, 2 is mapped to A, and 2 is mapped to B. Here is the violation. Also, this is also violation in the domain, because the domain, every element must be mapped to a unique element if it is 1 to 1 or to a single element. But 2 is mapped to 2 elements. The number 2 is mapped to 2 elements, which is A and B. So this is the violation for this particular one. So the mapping violation is at the domain. This is not a function, it is a relationship. Now that we talked about functions and relationships and the violations, let's get going and move a little bit more to do some more work by characterizing the linear functions. And we will characterize the linear functions in different ways. So let's go ahead and start. Every element in the domain must be mapped to a single element in the range. And this is the condition for a function, one of the conditions. The mapping may include at least one element in the range. That means the range can be onto, that means we map to every element, or we can map to some of the elements. Even one element would be more than enough to map to. There are 3 types of functions: even function, odd function, and neither even nor odd. We will just use neither for them. So let's take a look at some of these functions. We looked at this function, and this is another one. This is a third function. So let's take a look at them. This is not a function, obviously, because there is a violation in the domain, which is we have a 2 that's not mapped. And this function is 1 to 1, 1 to 1. And it's obviously clear it's 1 to 1. We have 3 elements in the domain, 3 elements in the range. And the mapping is 1 to 1. So we don't see any element in the range mapped to by more than one element from the domain. So this is 1 to 1 mapping. And this is neither 1 to 1 nor onto. It's not 1 to 1 because 1 and 3 are mapped to C. and it's not onto because b is not mapped to by the function. Let's take a look at these three functions. These three functions satisfy the following. This is an odd function. We will look at the condition that makes this one odd in a minute, and this is even function, and we will also look at the condition that makes this function even, and this is neither even nor odd. So we will take a look at the equation for each function and the condition for each function. So the equation for the function that's neither even nor odd is f of x equal to x plus c. That's the simplest equation for a linear function that's neither even nor odd. X plus c, where c is a constant. So for this one, it won't pass the test for a function if it is even or not, and it won't pass the test for a function if it is odd or not, and that's why we just call it won't pass either test, and that's why we call it neither even nor odd. Let's take a look at the function that's even function. F of x equal to c. Why it's even? This is the test for a function if it's even or not. F of negative x must be equal to f of x. That means regardless of the value of x, they must be having the same value for y. So if we look at this carefully, f of negative x, and our x is 1, so we know that f of negative 1 is equal to c, and f of positive 1 also equal to c. So they're equal. So f of negative 1 equal to f of positive 1 equal to c. So this is the test. So this function passes the test as an even function. Let's take a look at this function. This function maps -1 to -1, +1 to +1, and the function is f of x equal to x. And the condition is that f of negative x must be equal to negative x, and it also satisfies it. Let's take a look at how it satisfies it. If we put f of negative 1, so negative 1 is mapped to negative 1. So if negative 1 equal to negative 1. But negative 1 is equal to negative of f of 1, because f of 1 equal to 1. So negative f of 1 is equal to negative 1. So that proves that this function is an odd function. So these are the conditions. If this condition is satisfied for every x in the domain, the function is odd. If this condition is satisfied for every x in the domain, then this function is an even function. And if neither of these two conditions is satisfied for a function of this type, then the function is neither even nor odd. That's it for this video, and thank you for watching. Our next video will include characteristics of nonlinear functions and examples of different functions. Please subscribe to our channel. You stay healthy and you have a good day. Thank you for watching. Bye-bye.